Hello, we are the Group 6 and we are now to present Chapter 9 and it's all about Database Management System. After this chapter, you will be able to understand the operational problems inherent in the flat file approach to data management that gave rise to the database concept. Understanding the relationship among the defining elements of the database environment. Understanding the anomalies caused by unnormalized databases and the need for data normalization. Be familiar with the stages in database design including entity, identification data, modeling, constructing the physical database, and preparing user's view. Be familiar with the operational features of distributed database and organize the issues that need to be considered in deciding on particular database configuration. Overview of the flat file versus database approach. First is a flat file approach is an organizational environment in which users own their data exclusively. Data attributes is the most elemental piece of the potentially useful data in the database. Data redundancy is the state of data elements being represented in all users' file. Data storage is an efficient information system that captures and stores data only once and make this single source available to all users who need it. Data updating is the periodic updating of data stored in the files of an organization. Currency of information is the problem associated with the flat file model because of its failure to update all the users' file affected by a change in status may result in decisions based on outdated information. And lastly, task data dependency is the user's inability to obtain additional information of his or her needs change. Flat file data management. As you can see, the users had mentioned a while ago in a flat file system was being owned by the data. The data files were owned by each of the users. Let's see, you have a users 1 here in this transaction. Then it has a program then that they own which is a data A, B, and C. Also another users. Number 2, accessible in data X, B, and Y. And also users 3 have the program. 3 will be also the date L, B, and M. As you can see, here each of this data, the various user has this particular letter B. The data, this is just the discrete of disadvantage of flat file or file-oriented processing wherein there is a data redundancy. So, what is data redundancy? Data redundant always have letter B in the data, which is supposed to be where the organized database management system that we could be able to come up with a system that contains all of this data. Also, we see here that each of the users has their own program. What if they're also the same program, but they choose it individual and all the program are redundant, and that is disadvantage of flat file. Data storage and efficient information system capture and stores data once and makes this single source available to all users who need it. To meet the private data needs of users, organization must incur the cost of both multiple collection and multiple storage procedures, which create excessive storage costs of papers, documents, or magnetic form eventually. Why the excessive list storage if the data per users, they have their own data storage, so excessively amount of data storage if there is too many users, most likely it would cost a lot. Data updating or organizations have a great deal of data stored on master files and reference files that require periodic updating to reflect operational economic changes. When users maintain separate files, any such change must be made separately for each users. This adds significant the cost of data management. Any change or addition must perform multiple times illustration. Lately, you will update the data about letter B, and it will happen then each of the user's data will be updated. So 3 times will update the system, and if it is okay, system will update only the particular 3 users. Currency of information, the problem of multiple updates, and the problem of failing to update the files of all users affected by a change. If update messages are not properly disseminated, then some users may not record the change and will perform their duties and make decisions based on outdated data. In terms of currency information, whenever there is multiple update not properly disseminated the update, then will be failing to update all the file, especially about the current. Task dependency. Another problem with the flat file approach is the user's inability to obtain additional information as his or her needs change. The user's information set in constrained by the data that he or she possesses and controls. Thus, data dependency is the user's inability to obtain additional information as needs changes. Database approach. The most obvious change from the flat file model is the pooling of data in a common database that is shared by all the users. Pools data is a common database shared by all users which resolve problems. Database concept presented a simple overview of the database approach with the same users and data requirements as in figure 9-1. The most obvious change from the flat file model is pooling of data in a common database that is shared by all the users. Flat file problems. Solve. Data sharing is the central concept of the database approach. No data redundancy. Data is stored only once, eliminating data redundancy and reducing storage costs. Single update. Because data is only one place, it requires only a single update, reducing the time of cost of keeping the database current. Current values change to the database made by the users yields current data values for all other users. Thus, data independence. As users' information needs to expand, the new needs can be more easily satisfied than the flat file approach. Controlling access on the database. The database approach places all the firm's information eggs in one basket. It is essential to take very good care of the basket. Database management system. The database management system is a software system that controls access to the data resources. The DBMS is a special software system that is programmed to know which data elements each user is authorized to access. The database concept, as you can see, 3 users, we have different programs. These 3 programs will be integrated to the database management system. And our database management system will have only one storage with all the data users. 1 or 3 in the flat file system will only be included in the database. 3 conceptual models. The hierarchical model is a database model that represents data in hierarchical structure and permits only a single parent record for each child record. Users are individuals who employ systems, receive information, and act on the information received. The relation model is a data model that is more flexible than traditional navigational models. It allows users to create new and unique paths through the database to solve a wide range of business problems. Navigational models are models that possess explicit link or paths among the data elements. The internal views is the physical arrangement of records in the database. Elements of the database environment. The database environment is broken down into 4 primarily elements. First is the users, second is the DBMS or the database management system, third is the database administrator, and the fourth is the physical database. Elements of database concept. So, in this particular illustration, it shows to us the elements of database concept, although in the next slide, some of it will be discussed. So, the first element that is very important that you can see is the user. The user is the one who accesses the database, and it can access the database in two ways. Number one is through the use of the user's application program that system professionals have already prepared. It's or the other way how these users can be able to access in by a query wherein requires no formal user program. Database concept will be database administrator who manage the database management system. As you can see, we have a physical database which is also an element in the database concept, and this consists now the element. We have the users which can use the query or application users program, and we have also database management system. Another element is the database administrator and physical database. Database management system. Data definition language. Data definition language is a programming language used to define the database to the database management system. Internal view, conceptual view. The schemas is the description of the entire database. User view. The user view is a set of data that a particular user needs to achieve his or her assigned task. DBMS operation. Access method is a technique used to locate records and navigate through the database. Review of DBMS operation show how to users access the database in two ways. The first is via user application program. The system professional prepare. This program sends the data access request to the DBMS, which validates the request and retrieves the data for processing. Under this mode of access, the presence of the DBMS is transparent to the users. Data processing procedures for the transactions such as sale, cash receipt, and purchases are essentially the same as they will be in the flat file environment. The second method of database access is via directory, which requires no formal users programs. The DBMS is a built-in query facility that allows authorized users to process data independent of professional programmers. The query facility provides a friendly environment for integrating and retrieving data to produce and manage reports. This feature has been an attractive incentive for users to adopt database approach. The database management system. Data manipulation language. Data manipulation language is the language used to insert special database commands into application programs written in conventional language. Query language. The index essential file is an essential file structure accessed via an index. Example of select command used to query an inventory database. You can see this is the example of the select common use query an inventory. The database administrator. The database administrator is the individual responsible for managing the database resource. Organizational interaction of the DBA. The data dictionary. The data dictionary is the description of every data element in the database. Function of database administrator. Database planning. Develop organization database strategy. Define database environment. Define data requirements. Develop data dictionary. Design. Logical database. Internal users. Internal view of database. Database control implementation. Determine access policy. Implement security control. Specify test procedures. Establish programming standards. Operational and maintenance. Evaluate database performance. reorganize database as user needs demand, review standards and procedures, change and growth, plan for a change and growth, evaluate new technology. Organizational interaction of the database administration. So, database administrator is a person who has the position that does not exist in the flat file environment. So, we don't have database administrator in a flat file environment because we don't have a database management system. So this database administrator is responsible for managing the database resources, and also one function of it is more on database planning. The one will develop an organization database strategy, define the database environment, define the requirements and development the data. Dictionary, so another also responsible is the design of the schemas, and also the one who implement what is being planned and will maintain the database, and this talks about the change and growth about the database management. The physical database is the lowest level of database containing magnetic spot on the magnetic disk. The index sequential file is the sequential file structure accessed via an index. The inverted list is a cross-reference created from multiple indexes. Index sequential file. One contains the employee number or primary key for uniquely located records in the file. The second index contains record addresses arranged by year-to-date earnings. Using the unique field as a secondary key permits all employee records to be viewed in ascending or descending order according to earnings. Alternatively, individual records with selected earning balances can be displayed. Index may be created for each attribute in the file, allowing data to be viewed from multitude of perspectives.
So let's proceed to the relational database model. E.F. Codd originally proposed the principles of the relational model in the late 1960s. The formal model has its foundations in relational algebra and set theories, which provide the theoretical basis for the most of the data manipulation operations used. A system is relational if it is 1. Represents data in the form of two-dimensional tables such as the database table called customer. 2. Supports the relational algebra functions of restrict, project, and join. So this is an illustration showing a relational table called customer and the relational algebra functions restrict, project, and join. Next, we have the data modeling concepts. A data model is a blueprint for what ultimately will become the physical database. A top-down approach requires a detailed analysis of the organization's information needs. The bottom-up approach is when a client organization's database developers may modify the model to suit the company's specific needs. Next is entity, relation, occurrence, and attributes. An entity is a resource, event, or agent. The entity relationship or ER diagram is the documentation technique used to represent the relationship among data entities in a system. An entity-level ER diagram is a high-level perspective of the overall schema, which presents only the key entities and their relationships. It does not show the data types and keys contained within the entities. A relation describes how data in one entity are related to data in another entity. Occurrence or instance is used to describe the number of instances or records that pertain to a specific entity. Attributes. Attributes are the equivalents to adjectives in the English language that serve to describe the objects.
So here is a illustration that shows data model using an entity relationship diagram. The customer buys product and also the customer sends payment. Next, associations and cardinality. Association describes the relationship among record types, and cardinality is the numerical mapping between entity instances. The physical database tables. A tuple is the formal name for a row in the table. Primary key is the set of characteristics that uniquely identify each record in the tables. Linkages between relational tables. Foreign keys are keys that permit the physical connection of logically related tables to achieve the associations described in the data model. So here is an example of entity associations. Employee is assigned a company car. Example number 2, manager is provided a laptop. Example number 3 is customer places sales order. Maybe it is in a department, sales department. Example number 4 is vendor supplies inventory. Number 5, vendor supplies inventory. And number 6, example number 6, customer maybe receives payment. Here is also a figure that shows linkages between relational tables and a figure that shows relationship between user views and entities. Next, anomalies, structural dependencies, and data normalization. Database anomalies. Anomalies are negative operational symptoms caused by improperly normalized tables. The first normal form, or 1NF, is the low degree of normalization of relational database tables. The second normal form, or 2NF, is the table that is free of both repeating group and partial dependencies. The third normal form, or 3NF, is the normalization that occurs by dividing a normalized database into smaller tables until all attributes in the resulting tables are uniquely and wholly dependent on explained by the primary key. The update anomaly is an unintentionally updating of data in a table resulting from data redundancy. The insertion anomaly is an intentional insertion of data into a table. The deletion anomaly involves the unintentional deletion of data from a table. So here is a figure that shows inventory status report, a figure that shows a normalized database table. Let us continue anomalies, structural dependencies, and data normalization. Normalizing tables in a relational database. Repeating groups occurs when multiple values for a particular attribute exist in a specific tuple. Partial dependencies occurs when one or more non-key attributes are dependent on, defined by, only part of the primary key rather than the whole key. Transitive dependencies occur when a table where non-key attributes are dependent on another non-key attribute and are independent on the table's primary key. So this is a figure that shows steps in the normalization process. First, user view represent view with a single table. Second, a normalized table. Remove repeating groups, and then table in first normal form, or 1NF. Remove partial dependencies in the table or in the second normal form, 2NF. Then remove transitive dependencies in third normal form, or in the 3NF table. This is what a user view looks like. It has prod number, description, quantity, unit price, and exact price, I think.
Next, represent the view as a single table. Represent the view as a single table that contains all of the view attributes. This is a figure that shows a normalized table supporting user view. As you can see, the first three rows is data repeatedly input, that is called data redundancy, and the last three rows here is starting in prod number and to X price is a repeating group data. Remove repeating group data. The first step in correcting structural dependencies is to determine if the table under review contains repeating groups. A composite key is comprised of two attributes, invoice number and prod number. This is a figure shows resulting tables after removing repeating group data and calculated fields. This is how the table will look like if we remove the redundant datas and repeating groups in the inputted datas. It will look more organized and pleasant to see. Remove partial dependencies. A partial dependency occurs when one or more non-key attributes are dependent on only part of the primary key rather than the whole key. This can occur only in tables that have composite two or more attributes, primary keys. This is a figure that shows resulting table after removing partial dependencies. And then this figure compared to resulting tables after removing repeating group data and calculated fields, it will more look like easy to understand. It has only invoice number, prod number, description, quantity, and unit price in the line item table. Next, remove transitive dependencies. A transitive dependency occurs in a table where non-key attributes are dependent on another non-key attributes and independent of the table's primary key. Resolve the transitive dependency by splitting out the customer data and placing them in a new table called customer. This is a figure that shows resulting table after removing transitive dependency. Now the table only has invoice number, order date, ship via, customer number, customer name, street address, city, street, and telephone number. The customer number up to telephone number is a transitive dependency. The sales invoice table is the invoice number or order date, ship via. And the customer table is the customer number, customer name, street address, city, street, and telephone number. Here is a figure that shows linkages between normalized tables. First, we have the sales invoice table. The primary keys are invoice number, order date, shift via, customer number. All informations about how it is being purchased is under sales invoice table, and then in the table below is the line item table, which contains the items information, which is invoice number, product number, and quantity. And next, inventory table. Here is another group of data that is meant for inventory.
which includes product number, description, unit price, and other datas that relate to the product. And the table above is the customer table, which includes the information about the customer or the buyer. It includes customer number, customer name, street address, city, street, and telephone number. And this is the illustration that shows applying the 1M key assignment rule. This is how the inputted data will look like if we apply the 1M key assignment rule. In addition, normalization is a technique of organizing the data into multiple related tables to minimize data redundancy. I realized that normalization is one way on how to reduce data redundancy in your data informations, and this will help you to make your information presentation look like more presentable and more easy to understand.
So, next is the normalized database tables wherein yung inventory table is nakalagay yung part number, description ng products, and of course, the quantity on hand ng product and the reordered points sa products. And dun sa part or suppliers link tables, which is nadoble dito yung part number ng nag-order but the supplier number is magkakaiba. And meron ding nadoble but same person lang din naman yung nag-order. Kaya, dito sa supplier table, inayos nila yung data wherein the supplier number is wala na siyang na doble-doble, and of course, yung name ng susuplayan and yung address niya, and of course, yung telephone number niya. Then, next will be the top-down approach to designing relational and databases, wherein view modeling determines the associations between identities and document them with an ER diagram. So, number 1 will be identify the views to be modeled. Next, normalize the data model and primary keys. And third, determine cardinalities and add foreign keys. And fourth, construct physical database. And fifth, prepare the physical user's view. So, under this view modeling is that view modeling helps to create and simplified logical databases which eliminate redundant and reduce storage requirements. So under view modeling is number 1, identify the views to be modeled. So as it says here that view modeling begins by identifying the relevant view of the business functions in questions. The involved user interviews and the other techniques to determine what users do and what information they need to support their tasks. So as you can see, ang nakapaloob dito sa identify the view to be modeled is that nakalagay dito yung mga kailangan or yung mga kailangan i-identified sa relevant views ng business organization or functions. Especially doon sa kung paano or yung mga paraan ng techniques na ginagamit nila at mostly yung information na kinakailangan for them to support their tasks in the organization and para ma-identify yung mga problems na pwedeng mangyari. So, next will be purchase order and receiving report for purchase system. So, as you can see, there is 2 tables here wherein ang unang table which is purchase order na kung saan tinutukoy dito yung about sa purchase order na information sa pag-purchase, nakalagay yung purchase number, yung supplier number, and of course yung address, the order date, the date required, and supplier number. And of course, yung terms ng product. And Part number, yung description ng product, yung quantity, unit, and the extended cost. So, sa letter B, tinutukoy dito yung pag-receive ng report sa product, which is yung date receive, kung kailan na-receive yung product, yung purchase number ng product, yung carrier code, and of course, yung BOL number, wherein BOL stands for Bill of Lading, na kung saan it is used for specific load or shipment ng products, wherein these are the references that helps to tie yung shipments to tracking system. Then, sa baba naman niya is yung mga part number, description, and the quantity received, and of course, yung condition code ng product. So, next will be the unnormalized data model showing primary keys and attributes, na kung saan pinapakita dito yung mga data which is unnormalized siya. And of course, hindi siya maayos na nailagay. We're in dun sa status report, by part number, and of course, yung mga information na kailangan. And dun sa receiving report, meron din siya, but hindi meron din. And of course, dun sa purchase POR number, information na kinakailangan for the transactions. So, next naman is yung normalized data model, na kung saan yung inventory model is that nag-a-update siya dun sa record report ng item details, and dun yung record report ng item details is that nagko-contain siya ng receiving report, which is the record receipt number, the PO number, and the date, and the to prepaid, and of course the collect. While in the inventory, dun sa baba na inventory is that nagsusupply siya ng information about dun sa inventory supply link, yung part number, and the supplier number ng data. Through inventory supplier link is that nagsusupply siya ng information dun sa mga supplier, yung sa number ng supplier, and of course dun sa supplier telephone number. And for the last one is yung part number is pertain siya dun sa purchase order details, yung mga number, and of course yung order quantity ng pag-purchase sa product. And nagko-contain siya din ng purchase order, yung purchase number, and the supplier link, which is associated dun sa receiving report and the purchase order, wherein dito yung mga date collection, of course, then, and yung billing and of course yung the requested delivery date ng mga number, wherein as you can see, normalize na yung data dito, which so next is determine cardinalities and add foreign keys. The next step in view modeling is to determine the cardinality between entities and link the entities with the foreign keys. And view integration involves combining the data needs of all users into a single schema or enterprise-wide view. So under this is that it is very important to determine the cardinality of the number between entities data para ma-link sa entity with a foreign key, wherein foreign key is it is to identify the relationship between the database task by using columns or set of column in which is as a base or as a reference in the primary keys. So, yung view integration is that it is the collection and combining of alphanumerical data and features data that all users needed in the organizations. So next will be the construct the physical database, wherein create the physical tables and populate them with data. Next, this is an involved step that must be carefully planned and executed and may have many months in a large installations, and programs will need to be written to transfer organization data currently stored in the files or legacy databases to the new rational tables. Na kung saan ang constructed physical data is that it is designed to process the transforming of data model in the physical data structure and to avoid unnecessary data redundancy. Then, sa pag-construct ng physical database is that kinakailangan dito ang pag-iingat, lalo na sa pag-execute ng data para mas magamit at mas ma-access ang iba't ibang info between each data source and of course dun sa business or dun sa organizations. Normalized tables. So as you can see in this normalized table is that nandito yung info about the supplier, info about the inventory rather, then yung purchase number details which is combined siya ng key na tinatawag kanina, and of course yung purchase order and the receiving point and the record item detail, and of course the inventory or supplier link ng transaction, and of course yung supplier wherein nandito yung mga supplier name, yung mga infos ng suppliers. So dito sa baba niya is that yung user's view or yung purchase order na kung saan inayos na nila yung mga data sa taas na at nilagay nila sa table, which is yung purchase order, nakalagay na yung supplier name dapat meron, and of course yung supplier's address dapat hindi yun mawala, and of course the telephone number, yung order date kung kailan in-order yung product, and of course the date required, and supplier's number. And dito sa pinakababa niya is that part number, which is nakalagay yung description ng product, and of course yung order quantity ng product, and the unit cost, and of course the extended cost na total cost ng product. So next, we prepare the physical user views. The normalized table should be enriched enough to support the views of all users of the system being modeled. Database developer use SQL to identify which tables to be used and which attributes to be selected to create the user view. The report program is used to make the view visually attractive and easy to read. So, dun sa prepare the physical user view is that ina-emphasize dito na dapat yung mga ginagawang normalized data table is that nandun lahat yung data which is enough na maintindihan ng mga nangangailangan nung data or yung mga nagbabasa ng data. And of course, to view the length ng lahat ng mga, especially dun sa transaction, and of course dun sa task that is happen dun sa organization. And yung SQL na tinutukoy dito is that structured query language, na kung saan para mas ma-identify kung anong tables ang gagamitin at kung anong attributes ang dapat ilagay for them to create info of the user's view. At ang SQL or yung structured query language is ginagamit to access and manipulate data, at ginagamit din ito for programming and design to manage data and to support in a relational database management system. So next will be the commercial database system. Commercial systems are designed to apply with a proven industry best practices and to satisfy the common needs of different client organizations. Working from a commercial database package, developers can thus focus on configuring predefined views to accommodate specific user needs within the organization rather than starting from scratch. So as you can see, mas nagbibigay or nagkakaroon ng info yung mga iba through this commercial database system, na kung saan ang commercial system is dinesign para magkaroon ng references yung mga iba't ibang client dun sa organizations. At of course, para magkaroon na din sila ng kaalaman. And yung developer design is to further figure and accommodate yung mga reports or yung mga data na kinakailangan na information, especially dun sa nag-start ng business. Databases in distributed environment. Distributed Data Processing or the DDP is organizing the IT function into a small information processing units that are distributed to end user and placed under their control. An important consideration in planning a distributed system is the location of the organization's database, na kung saan yung DDP is a small computer network method na kung saan ito ay mga multiple computers across different physical locations. And sa paggamit dito, mas malilesen and costly yung pagsesend ng information to the other organization or other user who needed the data information. And especially dun sa business, sa paggamit ng multiple personal computers or network, mas less yung pag-invest ng single large data processing system. Centralized databases. So under this is that centralized database is a database retained in a central location. Meaning, nasa gitna lang or iisang location lang yung kung nasaan yung data or yung files. And yung centralized location is accessed via an internet connection gaya ng LAN or yung WAN. And mostly ginagamit ito ng mga institution or mga organizations. Kasi mas easy na ma-access yung mga data at mas madali i-stored ito in a single, kasi nakalagay na nga siya dun sa single location or naka-store na siya dun sa single locations. So next will be the data currency in this database distributed processing environment. So temporary inconsistency occurs during accounting transactions. Account balances pass through a state where the value are incorrectly stated. So, dun sa temporary inconsistency, nangyayari ito during yung accounting transaction, and of course, accounting transaction na kung saan dito mako-correct or makikita yung mga incorrect data na nangyari dun sa transactions of the organizations. Database lockout is a software control, usually a function of the DBMS, that prevents multiple simultaneous access to data. Na kung saan yung database lockout is a kind of software controlled multiple simultaneous data. Yun nga yung sinabi ko kanina, and of course, ginagamit ito as serve to protect shared resources or objects gaya ng tables, data rows, data blocks, and connection, and of course, the entire system to avoid hacking of the data. So next is the distributed databases, wherein as our databases contributed using either the partitioned or replicated techniques. Na kung saan yung distributed database consists of two or more files located in different sites, either in the same network or entirely different network na nakalagay yung data. And next is the partition databases. And partition database is a database approach that is split the central database into segment or partition that are distributed to their primary users. So, sinasabi dito that ang partition databases is a division ng logical databases which allows tables index and index organized tables to be divided wherein it enable this database object to be managed and accessed by the organization. And partition database is used to increase controllability, performance, and availability ng large database object, which also improve the performance of the transactions. Then next is the deadlock phenomenon, or a deadlock is a wait state that occurs between sites when data are locked by multiple sites that are waiting for the removal of the locks from the other sites. So as you can see, yung data lock is occur when two or more operations already want to access information looked by other one. So this is the unwanted situation in which two or more transactions are or must wait para ma-access nila yung data. And yung deadlock resolutions naman is that can reduce by ensuring that all application access their common data in the same order. Replicated databases, wherein replicated databases is a database approach in which the central base is replicated at each site. And tinutukoy dito that ang database approach is when the central database give information to each other. Replicated database pertains dun sa process of copying data from central to one or more central base. So, in figure 9-29, it's about centralized database, wherein site A to site F shows how they get information in the centralized site, wherein they request information dun sa iisang network lang or iisang sites, which is the central database. Then next is the distributed databases. Concurrently control. Concurrently control is a system that ensures the transaction process at each site are accurately reflected in the databases at all other sites, and distributed databases and the accountant. Then next will be the partition databases approach. So as you can see, the site A, which is the primary users of data A and B, is that nagre-request sila ng data dun sa site 3, which is primary users ng E at F, at yung E at F naman is nagre-request din naman ng data dun sa A and B. As long, ganun din naman dun sa C and D, nagre-request ng data siya sa A and B, which is all of these three are requesting data to each other. Next is the deadlock condition. As you can see in the deadlock condition is that, sabi dito, inaantay muna yung data doon sa isa, which is, as you can see, lock A, wait for C. Bago mapunta yung data doon sa A is that kailangan niya muna na mapunta yung data dun sa C in order to get, which is it shows rotation of the data in the transactions. Next will be the replicated database approach. So dito naman is that iisa lang yung pinagkukuhan nilang data, and every sites is that may copy lahat ng data or may replicated data approach sa lahat ng information sa transactions. Next will be the replicated databases updated independently. As you can see, dun sa una, which is RA control, nagbibigay siya ng information dun sa site A and of course dun sa site B. And site A nagbibigay ng info doon sa RA controls, and site B nagbibigay din ng control sa RA controls, which is this RA controls dito sa baba is that the database inconsistent. Appendix distinguishing features of structured databases. Under this appendix is the hierarchical database model. Under hierarchical database model is the navigational database, limitation of the hierarchical model. Second is the network database model. And third is the data structures, wherein these are the techniques for physical arranging records in database. And hierarchical model data structure is a direct access method which is the root segment or the customer file of the database or organized as an index file. And under data structure is the network model data structured. So as you can see in the figure 9-24, which is the hierarchical data model. So nag-start siya sa root segment, then through root segment, yung mga data is that napunta siya sa file A, and then sa file A is that nag-distribute yung data sa set ng file B at file C. And yung file B na which is contain ng siblings data is that na-distribute naman siya sa file X, file Y, and to file C, which is a set of data of a siblings. Then next is the portion of hierarchical databases. So in the first box is that customer file. So customer file is that nagko-contain siya ng sales invoice at files. Then through files is that meron yung line item files ng customer file. And of course, yung cash receipt file ng customers. Multiple parents association. As you can see dun sa natural relationship, dun sa salesperson file and customer file is that napupunta yung information nila dun sa sales invoice files. And dun naman sa letter B, which is the hierarchical representation with the data redundancy, which is sales file is that napupunta or magkahiwa yung salesperson file at customer file is hiwalay kung saan napupunta yung information nila, which is sales invoice files, magkahiwalay yung dalawang info nila. Last two will be the linkage between file in the hierarchical databases. So as you can see, nandito yung mga information how customer person records, yung mga customer number, yung name, and of course yung sales invoice files ng customers, kung kaila customers, tapos yung pointers ng customers, and of course the line items files nila, and of course the cash receipt files wherein it shows how hierarchical database work and kung gaano ito ka-complicated in a business din. So last will be the linkage in a network databases wherein as you can see in salesperson, one is that it shows how invoice is, and of course yung customer file na number 2, number 5 is that nagpapakita din ng invoice dun sa on how invoice in purchasing product, and of course yung sa 3 customers how they interact, and of course the invoice and customers, and the sales invoice files ng mga customers, and of course the sales person's file. This is how linkage in a network database work.